Today we'll be discussing trigonometry. Let's start by introducing the values of basic functions sine, cosine, and tangent. Cosine and tangent. So let's start with the degrees. I'll write the degree values on top, and I'm going to make a table, and we'll write the values of these functions. So for 0 degrees, 30, 45, 60, and 90. So one trick that's always helpful to use is that sine 0 is 0. You can do 0, 1, 2, 3, 4. Take the square root of each and divide by 2. So this is actually just 1/2, and this is 1. We can do, now cosine x is actually just this, but backwards. So the value for sine 90 is actually the same as the value for cosine of 0. So this will be 1 square root of 3 over 2 square root of 2 over 2, 1/2, and 0. And for tangent is actually equal to sine x over cosine x. So then we can just divide these two values. So 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 is 1/2 times 2 over square root of 3. So it's just square root of 3 over 3. This will be square root of 2 over 2 divided by square root of 2 over 2, which is 1. This will be square root of 3 over 2 divided by 1/2, so equals to times 2 over 1, which is square root of 3. And this is undefined, because 1 divided by 0 is undefined. So let's write a neater version of the same table on the next page. So sine x, cosine x, tangent x, $60 and 90. And we'll use this table while we're solving the example problems that we're going to do. Square root of 3 over 3 and 0. Alright, so let's take a triangle with an angle here of 30 degrees, and the side opposite to that, the only length is given is the side that's opposite to this 30 degrees, and let's say that side length is 4. So now we can use these functions and their values here to determine the hypotenuse and even this side. So there's a mnemonic device that's used, SOHCAHTOA, and this basically defines each function in terms of a triangle. Sine, the S stands for sine, is opposite over hypotenuse. So in this case, it would be the 4 over this, so is equal to sine 30. And cosine will be adjacent over hypotenuse. And tangent will be opposite, the O and the A, TOA, over adjacent. So for this problem here, the value for the side opposite, the length of the side opposite to this angle is given, so we should use sine to solve for it. So sine of 30 is equal to the opposite 4 over the hypotenuse, which we'll label h. So now if we were to solve for h, we cross multiply, and you get sine 30 times h is equal to 4. And sine 30 we determined from above here. If you go on this table, sine 30 is 1/2. So 1/2 times h is equal to 4. H is equal to 8 if we divide 1/2 on that side. And that is the value for this. Now we can also use a tangent function, or we can use the Pythagorean theorem, but in this case let's use the tangent function to determine the side for this. We're using a tangent function because we have the opposite side and we want to find the value of the adjacent. So in this case it would be tangent 30 is equal to 4 over, let's label this side A for adjacent. So tangent 30 times A, cross multiply, is equal to 4. Tangent 30 from this table here is square root of 3 over 3 times A is equal to 4. So A we have that. So A is equal to 4 over square root of 3 over 3. It's also equal to 4 times 4 multiplied by 3 over square root of 3. So it's 12 over square root of 3. And if we want to get rid of the square root of 3 on the bottom, we can multiply it by square root of 3 on top and bottom, giving us 12 square root of 3 over 3. This simplifies, and you get a 4 on the top, so your answer is 4 square root of 3 in the end. So this side here is 4 square root of 3. So redrawing this triangle, all the values would be 8, 4, and 4 square root of 3. We can check our work by using the Pythagorean theorem. Squaring, if the side's A, B, and C, you can do A squared plus B squared is equal to C squared. 4 square root of 3 squared plus 4 squared is equal to C squared. And we should achieve 8 if we've done this correctly. And this is 16 plus. We should actually achieve 64 if we've done this correctly, because C is squared. So C squared is equal to 64. And this is 48. So that does equal to 64, so we have done our calculations correctly.